VSEPR theory to predict the shape of molecules using VSEPR theory. VSEPR, it's a valence shell electron pair repulsion, allows us to predict the shape of the molecules to better learn their properties. They are in 3D versus 2D Lewis structure. Molecules will assume arrangement that minimize the repulsion between the electron pair around the central atom. Let's talk now about the VSEPR models. We have a linear shape, so if only two bonds pair, like CO2, and the angle it's 180, the shape is linear. And we have bent, two bonded and one or two lone pairs, like sulfur dioxide and water. So the geometry here called bent. If we have three bonds pair, trigonal planar if only three bonds pair, and like boron trifluoride, and the angle it's 120. And we have CH2O trigonal planar as well. And we have trigonal bipyramidal, it's when three bond and one lone pair, like ammonia NH3, it's called trigonal bipyramidal. If we have four, we call the geometry tetrahedral, like CH4, and the angle it's 109.50. And also we have geometry called seesaw if we have four bonded and one lone pair, like sulfur trifluoride. So if we have five now, we call trigonal bipyramidal, and we have phosphorus pentacarbon or pentachloride, whatever. The last one, if we have six bonded, we have octahedral, like sulfur hexafluoride. Let's now take some examples from AP textbook. It's on page 378. We have carbon tetrachloride. We need to fill Lewis structure and to write AXMN notation. A is a central atom, XM is the bonded electrons, and E lone pair electrons or unbonded electrons. And after that, we should draw the molecular shape and we name it. Let's go. Start with CCl4. We know it's 1 carbon times 4 plus 4 chlorine times 7, so totally 32 electron. This 4 valence electron. We put the carbon as a central atom and put chlorine 4, and we reach each atoms to octet rule. And if we calculate, these electrons should be 32. Because we don't have any lone pair electrons unpaired, so the notation it's AX4, and the geometry is tetrahedral. The shape should be like here. This is called tetrahedral geometry. Another example, we have phosphorus trifluoride, 1 times 5 for phosphorus plus 3 times 7 for fluorine. The total electrons is 26 electron. So we have B, F, and reach the octet rule, because fluorine make usually a 1 bond. If we calculate it, it's a 24, so we still have to, we put it on central atom as we learned in the previous video to draw Lewis structure. AX3, because we have 3 atoms bonded and 1 lone pair electron, so AX3E. The geometry is trigonal, pyramidal, and the shape, it's like ammonia. This is called trigonal pyramidal. The last one, we have sulfur dichloride. So it's 1 times 6 for sulfur plus 2 times 7 for chlorine, and the total is 20 electrons. So we have S, Cl, and Cl. Here as well, if we calculate it, we 1, 2, 3, 4, 5, 6, 7, 8, so it's 16. We need 4, put it 2 here and 2 here. AX2, E2, and the shape should be bent like water, so it's sulfur and chlorine. Thank you so much.